Our friend seems to be awakening. Where is this? Where am I? Do not be alarmed, my friend. My man is gone punch out of the cliff. Brought you here to take care of.
Welcome, everybody. Please join us in welcoming Dr. Vint Cerf.
It always makes me nervous when people clap before you've said anything. And it makes you want to just sit down because it won't get any better than that. First of all, thank you very much for joining us this afternoon on a lovely, what should be a winter day. It didn't look like what I was anticipating when I was told we're coming here to Ottawa for 3 days to talk about internet governance and policy. So thank you for bringing pleasant weather to what otherwise would have been difficult. I want to recognize John Robertson, who's here in the front row. He is sort of the Canadian father of the internet. He's at the Canadian Research Center, but he's been involved in this forever. John, welcome. This is simply illustrative of the fact that the internet is not an invention of two people, although Bob Kahn and I indeed started the project when he was at ARPA and I was at Stanford. But this is the sort of thing that has many, many hands to make it work. And it was very international from the very beginning. So I had people at my Stanford laboratory from France and from Norway and from Japan. We had cooperative groups at the University College London. I had German and Italian participants, and we even had an international network working group, John, which you remember, that had membership from others as well. So much of what happened in the internet evolution is a collaborative activity and global in scope. And I think I want to start out by reminding you that one of the themes of the design of the protocols and the architecture was openness, keeping everything as open as possible. So it was possible to develop new protocols adjacent to the existing ones, to introduce new underlying transport mechanisms to support the flow of internet packets, so that when optical fiber cables were invented, which was and started in use in the early 1980s, the internet design, which was begun in 1973, was able to absorb that technology. So we were very conscious of and tried very hard to keep everything very, very open to new ideas and new contributions. And the same thing is true of the fundamental architecture. Remember, it's a network of networks. There isn't any central control. Anyone who could build a network that had the proper characteristics and executed the protocols as specified should be able to interconnect and interwork. We left it to each of those network operators to pick whatever business model they wanted, to decide which hardware and software they were going to use, to decide on what terms and conditions they would connect with other people. So the system grew in a very organic way, in part because of that openness. And this is probably the most important characteristic that I think we want to preserve so that others can continue to evolve the net and make use of it. The same thing is true of the institutions that grew up around the internet. They were created at need as opposed to all at the very beginning. An example is the Internet Engineering Task Force, which started out as the Internet Configuration Control Board, which I had created to act as a brain trust back in 1979 in case I got hit by a bus. And we gave it the organization was called the Internet Configuration Control Board to sound as boring as possible so nobody would want to be on it. And that way I could pick the people who were leading the research projects to populate that. Well, eventually that grew up into the Internet Architecture Board and eventually spun off the Internet Engineering Task Force and the Internet Research Task Force. And we kept doing that. The Internet Society, the Internet Corporation for Assigned Names and Numbers, the regional Internet registries, all got created as the need arose. And I'm supposed to only go for 10 minutes here, and I'm already way over time. I would also argue that openness is part of the implementation because people were free to go build their own software. They didn't have to take software from any one source, and so we had multiple sources. Part of our motivation was to find a way to allow people to use computers to communicate with each other and to share their information, to share their computing resources, and share their software, all in aid of research, because in the early stages, this was the Defense Department's project. We also wanted very much to keep the barriers to access to this capacity as low as possible. So we tried very hard to make it very easy for people to get access to the system. To make it, when it became commercially available, we wanted to keep the costs down. We wanted to keep the capacity to allow this interaction to happen to be let's say, as freely accessible as possible. It didn't become available to the general public until around 1989, when the first commercial internet services started in the United States. Prior to that, the only commercial developments that of note were people building routers like Cisco Systems and Proteon. And they had to do that because the way we used to do routers was to take a computer and a graduate student, and you wrap the graduate student around the computer and turn it into a router. And we ran out of graduate students, and the Cisco guys figured out that they could sell that product. But by the time we got to commercial use, we had a very rapid growth in demand for internet service, which accelerated with the invention of the World Wide Web. Tim Berners-Lee released that design in 1991, and nobody noticed except for a couple of guys at the National Center for Supercomputer Applications in the middle of a cornfield in Illinois. And they built something called the Mosaic Browser, which some of you may remember. It was the first graphical user interface for the World Wide Web. And that caught everybody's attention, millions of downloads in the first several months, making it really easy for people to create information and to share it in very colorful ways. So it made the internet look like a magazine instead of just text. That caught the eye of a guy named Jim Clark, who had started Silicon Graphics out on the West Coast. And he came to NCSA and grabbed Mark Andreessen and Eric Bina and others, brought them back to the West Coast, and started a company called Netscape Communications in 1994. In 1995, they went public. The stock went through the roof, and the dot boom was on. The venture people threw money at anything that looked like it might have something to do with the internet. And around 2001, no, in April of 2000, some of the people who didn't know the difference between income and capital and didn't actually have a business plan went belly up, and that was the dot bust. But the internet continued to grow by factors of 100% in those early years. So the result is that we have very open access to the internet now. We have very low barriers for the sharing of information, the discovery of information, the generation of information. And now all the bad actors showed up. And so we started with this collection of geeks whose intention was to make the internet work. But then once it became available to the general public, we got what Shakespeare teaches us, which is that people have a variety of motivations, some of them which are not in your best interest. So today we have a real challenge because the network is used for abusive purposes, denial of service attacks, malware, spam, pornography, fraud. I mean, there are a variety of ills that populate the internet. And that's almost inescapable when you're dealing with the general public. So the challenge we now have is how to discipline this environment to maintain its value while at the same time reducing the level of potential harms that can visit people who are trying to use the network. And that's what we just spent the last 3 days doing in the Internet and Jurisdiction Conference that was held here in this, well, actually adjacent to us in the meetings. So I'll stop there. I went farther along than I expected to, Daphne, but why don't you come up and let's have a chat, and then we hope we'll have a little bit of time for some Q&A with our audience. Hi.
Thank you, Vint. Hi. Fancy meeting you here. Thank you so much for those remarks. I have to say I'm a little bit starstruck being on stage with Vint Cerf.
I'm just this old guy, been around for a while. Don't let it faze you.
So one of the most sort of inspiring things to me about the origin story of the internet is the lack of centralized authority, which you talked about some in your remarks. The idea that sort of operated through rough consensus and running code, the idea, and this blew my mind when I first learned about it, that instead of rules, there's something called a request for comments. Like what more humble and sort of multipolar, multi-authority approach could there be?
Do you know the story behind that?
No, I don't. Please.
My best friend, Steve Crocker, and I were in graduate school together at UCLA. There was a predecessor project called the ARPANET, which was sponsored by, surprise, the Advanced Research Projects Agency, so we called it ARPANET. And Steve, as a graduate student, was responsible for leading the effort to develop the host-to-host protocols so that computers could talk to each other even though they came from different brands of computer. And that was a big deal then because most of the computers couldn't talk to each other unless they were the same brand. Well, we're just graduate students, right? And there are principal investigators who are supposedly in charge. And so when he was asked to please lead this effort, he knew that it should get documented, but he wanted to be very careful about over-asserting himself, figuring, somebody would come in and wham. So the result is that he decided to call the documentation request for comments because that's what we were looking for. We were just sharing our ideas to see what would happen. Those have morphed now into the standards documents that describe how the internet works. And there's a lot more effort to get an RFC out the door than was required in 1969 when they were first initiated. That's where that came from.
So I love that story. I think everyone's here because we love that story. And the idea of this aggregate group of people coming together and comparing notes and building something. And what I want to ask you about is the shift to today's much more commercially driven set of internet technologies. So many more things exist because it was in the interest of a company to build them. And that's not necessarily a bad thing, but it does seem like it is a shift from this era when a number of, as I think of it, like public-minded technologists with the patience of saints, compared notes and made these things happen. How do you see that shift affecting both the architecture of the internet and the ways that the public interest gets baked into the design?
Well, I was one of the guys that, in fact, argued in favor of commercialization. Somewhere around 1988. Remember, the internet got turned on in 1983. We worked on it for 10 years before we actually turned the thing on, going through multiple cycles of protocol design and test. But in '88, I realized that the general public wouldn't get access to the internet unless we could build a commercial engine to support it. And so I was in favor of that. A lot of my colleagues said, "You're crazy. Why would you let the unwashed public into our playpen?" And I said, "Well, it'll never get in the hands of people who could contribute to it unless we found a way to do that." So I was a big fan of commercialization. And indeed, that's been an important sustaining factor in the internet's growth. We have not relied on governments to pay for everything. I think that you do get mixed into this a competitive element, which is sometimes good because you have competition for the same products, routers, for example, and the edge devices. But the standards of the net are what are still, they still adhere to a philosophy that says we don't really want license requirements to execute the standards, so to speak. So we try very hard in the IETF, the Internet Engineering Task Force, to adopt standards that do not require royalty payments, for instance. Or if they do, they have to be under what's called fair and reasonable use. So that's part of what disciplines the commercialization. Somebody who comes up with a completely different thing may have trouble getting anybody else to be compatible. The one exception to that is the end-to-end nature of the internet, which allows you to build an application in a mobile and a server somewhere, and those are the only two things that have to agree on how things are supposed to work. So you see a lot of apps showing up on mobiles that are unique in terms of their technology because it's possible to do that because you're in control of both ends. But this intent to make the openness persist through the technology of the internet is still there. And you would sense that if you were to go to one of those meetings. Even though the people who are there are often working for commercial companies, we sort of check our guns at the door in order to try to do something useful for the benefit of the internet and its users, not for particular companies.
So speaking of end-to-end design principles, I've been looking back at some, the ACLU v. Reno case, which is this founding US law case about free expression on the internet, and other materials from that time. And one of the very important assumptions that the courts were building on there was what's basically an end-to-end design assumption. It was the idea that you don't want to regulate what content flows along the pipes, because instead at the sort of client end, at the browsers or whatever you're using to access the content, individual users can exercise control, or parents can have means to exercise control for their children. That's something we don't hear about as much these days, and you could argue that what the courts did not anticipate was the role of Google and Facebook and big companies that offer some form of content curation before things reach the end user. And so I'm curious, sort of as you think about the role of end-to-end design as an engineering philosophy, but also as a way of maintaining access to information, whether you see any change over time there.
So I think we have to unpack what you just said in several dimensions, because the way you describe that lumps a number of different things together, so I'm going to try to unpack them a bit. The underlying basic protocol of the internet is called, amazingly, the Internet Protocol. And it's basically electronic postcards. Each little packet has a to address and a from address and has some content just like a postcard. The packets and the postcards share a lot in common, one of which is the postcard has no idea how it got carried. It could have been over in a car or a bicycle on the back of somebody's backpack or an airplane or something. That's also true of internet packets. They absolutely do not know exactly what transport medium moved them from place to place. The postcards don't know what you wrote on them, and this is true of the internet packets. They don't know what they're carrying. They just know that there's a bag of bits to be moved through the network. So the network itself, the underlying switching system, doesn't know what the applications are. That knowledge is held in the edges of the net where the bits get interpreted, which, by the way, is a wonderful feature, because if somebody wants to invent a new application, we don't have to change the network because it didn't know what the applications were. And so lots of new applications have come along, some of them in consequence of the increased capacity of the network to carry traffic. So in the mid-1970s, we were experimenting with packetized voice, and in the later 70s in packetized video. Now, you do this all the time, but back then, that was pretty new, pretty crazy, and we couldn't do very much of it because the backbone of the network was running at a blazing 50 kilobits a second. So we were still experimenting with that, partly because the system was supposed to be used for command and control. We knew they would need data, voice, and video to do that. So the underlying fundamental layer is still there, has not changed. When you start layering World Wide Web on top, for example, it's still a relatively neutral layer. It is largely unconscious of content. It's conscious of formatting, because that's what the HTML does. And it's content, aware of transport, because that's what the Hypertext Transport Protocol does. But it isn't, those protocols are not doing anything with regard to curation of content. So it's only when we get up to the point where some organization is either hosting content or indexing content that content becomes visible. In the case of Google, one of our most important and first products was Google Search. And it doesn't curate content in search. What it does is index the World Wide Web and then try to respond to queries. I'm sure everybody here is familiar with that. The one thing that is interesting and a challenge is that have you ever seen at the little bottom of the display after you do a Google search and it says 22 million hits were found in 0.012 seconds? And then the problem is, for us, which one do you show first, second, third, and fourth? And you got to organize 22 million hits. You can't put them all, on the one page, which is what some people seem to think they want. We want neutral search. What does that mean? It says all the hits that you got should be on the first page. And we say, that's fine. We can put it there in 0.0001 font, and we will rent you an electron microscope so you can read the hit. So we do, to the extent that you would consider that curation, we do a ranking, trying to figure out what data closely matches what you would seem to be looking for. In the case of YouTube, we actually host the data. The indexing stuff, we don't host necessarily. In the case of YouTube, we actually host the data. And there is a larger, let's say, expectation that there will be some curation, certainly some descriptions and so on, so you can find things that you're looking for, which, by the way, reminds me of an interesting phenomenon which I had a little trouble adjusting to. Today's younger generation, of course that's everybody at my age, but I mean, the kids that are in the 13, 14-year-old range, maybe younger, don't necessarily go to Google search anymore to find stuff on the net, which I was disappointed to hear. They go to YouTube instead. And so I thought, well, why would you do that? I mean, there's all this wonderful information in the World Wide Web. Until one day I was trying to figure out how to make Chinese Sichuan eggplant. And I really didn't get the best answer in the world out of the Google search, but I went over to YouTube and I got 13 videos showing me exactly how to make Chinese eggplant. And so I watched them all and then figured out how to do it, and we made Chinese eggplant. So now I understand why the younger folks are doing that. How do I do this is a very, very common part of the YouTube collection of videos. And that's kind of exciting in a way, because what that means is that you do just-in-time learning. You can say, instead of reading about something, you actually get to watch somebody doing it, and then you can try it out. And you'll make mistakes, and that's okay, you learn from them. So, the curation is there. I think it's almost inevitable when you have that much stuff in the environment. I still find it astonishing that anybody, Google and all the others, can cope with the scale of material that's on the net and make any sense out of it. I consider that to be one of the marvels of the modern age.
So one of the public issues that I understand is currently getting a lot of attention in Canada is a proposal that ISPs should be involved in blocking sites that are involved in copyright piracy. And you and I are just coming out of this 3-day event talking about legal interoperability, this idea of like, how do we make the laws in one country interact, play nicely with the laws of another country that might have different priorities about balancing values, such as free expression and privacy, or such as copyright protection and access to information, or whatever the balance is. And part of the answer from the legal perspective is we actually already have tools for that interoperability in the form of human rights agreements and in the form of treaties. There are rules, like written rules, that different governments have signed on to, and they might interpret them differently, but within the range of that agreed, I won't say protocol. That's reaching too far. You think it is? It's a protocol?
No, that's the right word. We borrowed, you hear this computer protocol stuff. We actually knew about the diplomatic protocols, and we said, wow, that's exactly right. It's conventions and practices that allow for this interaction to happen. And so we said, that's exactly what we want the computers to do. So we borrowed the term protocol from that. But you mentioned you were trying to stay away from acronyms. There's something called a Mutual Legal Assistance Treaty, or MLAT. And that is a set of protocols for countries to help each other in law enforcement, except it's very slow. And so I don't know whether it popped up in your sessions, but certainly in ours there was a great desire to reformulate the ways in which countries could interact with each other in order to be of help. If they both agreed that something bad had happened, a perpetrator in one country has harmed a victim in another, and they both agreed that that was a problem, then what are the mechanisms by which they can be of mutual assistance? And in today's world where things can happen at the speed of light, you have to figure out how to make those things work with much more alacrity than the many months that sometimes elapse before the MLAT processes finally take effect.
Yeah, in the sort of the content track where we were talking about speech and expression and content regulation, one of the proposals that comes up a lot at the national level is to have national ISPs block content. This is what Turkey did to Twitter for a while, for example. Maybe is still doing.
China does that to us at Google. A number of our services are blocked in China deliberately.
From a human rights perspective, there's a fair amount of criticism of this, and certainly within the inter-American framework, the free expression rapporteur of this human rights system, but also those of the UN level systems and other systems, really criticized the US when we tried to enact a set of laws called SOPA and PIPA that would have had a comparable effect there. So I know how the lawyers come at it, but I'm curious from a technological perspective how you see bringing in ISPs as the source of that kind of enforcement.
So first of all, let me try to be very precise for a moment. An internet service provider does a couple of things. Some of them are your access to the internet. That's the pipe that you get. You might have a cable company or a telephone company, a fiber network or something, or maybe it's a wireless connection, Wi-Fi. But that internet service provider is either giving you access to the network or it's part of the underlying infrastructure that's switching traffic through the rest of the network to get to a destination. We're down at the level of internet packets. And what's very important for you to know is that there is an increasing belief that the end-to-end traffic in the network should have the payload of the packets encrypted to protect privacy and confidentiality and even, by the way, integrity. Because once you've encrypted it, making changes will be very visible when you try to decrypt it at the other end. So at the layer of internet, literally internet service, I think that those organizations don't have very much role to play, especially if all the traffic is encrypted. Now, there is one very obvious thing that they are fully capable of doing. The thing that the internet service providers use to figure out how to route traffic is called an internet address. It shows up it's a numerical address and it shows up in the packets. And so you hand this to your internet service provider, essentially your software is saying, send this packet to that destination over there. It's certainly possible for an ISP to decide to look at that address and say, I've been told not to send any traffic there and block the traffic. And so it's entirely possible for an ISP, possibly at the demand of local government, to interfere with the flows of traffic, not based necessarily on inspecting the content, but simply based on what destination this is going to. To go up just a little bit, every network that you get access to use, your internet service provider, also has a service called a resolver, or a system called a resolver. It's taking domain names, which is what we typically use to refer to destinations in the internet, and translating those into numerical IP addresses. So we go from domain name to IP address, and then we route the traffic. It's possible for an ISP to be told, even if somebody wants to look up www.google.com, that you're not, if they ask for that, you should either give them a bad IP address or refuse to respond or refuse to route the traffic. And so you see this kind of interference at that level in the system. Higher levels of interference come when somebody says, I want you to stop any traffic that looks like it's copyright. And this is hard to do if it's all encrypted. So can I tell my anecdote about Jack Valenti?
Oh, please.
Jack used to run the Motion Picture Association of America. And you can imagine that his constituents were very concerned about intellectual property protection, certainly with an understandable reason. So Jack and I would occasionally be on stage in a public setting like this talking about intellectual property protection. And Jack would say, Vint, I want every router to ring a bell every time a copyright packet goes through it. You know, and I'm sitting here thinking, but Jack, do you have any idea what that means? And I said, look, imagine that you're the router, and a packet goes by whose content says, call me. And then a few hundred packets go by, and then another packet shows up, and it says, Ishmael. Okay, so now my router is supposed to figure out that it saw the beginning of Moby Dick. And it's got to figure out, did it come from somebody that had the right to send those packets or not? And then it's supposed to ring a bell. And so I told Jack that this didn't sound feasible to me at the 10 gigabit per second speed that we're running these days. And Jack says, you guys are smart, you'll figure it out. So I didn't succeed in winning that argument. We have an understandable desire to protect intellectual property. We could have arguments about how long that protection is permitted to last, but the principle is still there. Certainly in America, it's built into our Constitution. So I can understand that. There are other folks who, resist that. The real question is who should be responsible for enforcing this protection. This gets a lot harder, just like the router can't tell exactly whether some copyright packet went through it. Asking the ISPs to do this without, I would say, adequate preparation, legal preparation, makes me very uncomfortable, just like asking Google or Facebook or the others to do things without explicit legal instruction. Court orders are very helpful things because you can refer to them when you take an action in response to an order. But if it's some general desire that you do X, Y, and Z, this is really hard to ask a private sector company to make decisions. It's like the situation we have at Google with the right to be forgotten. We were given instructions to implement something, but not any instructions about how to make the decision whether we should or shouldn't cause a part of the web index to be removed. It also turned out to be really a weird thing to implement because we have to remember everything we have to remember everything we're supposed to forget. Because you have to remember to take stuff out of the index after you created the index. And of course that gets longer and longer and bigger, and after a while you have to remember more stuff than there is in the internet in case it comes back. So it's, the implementation of this is, from an engineer's point of view, slightly weird, even though the motivations behind it are sometimes understandable. And we get requests. We've just published a transparency report about the right to be forgotten with statistics in it describing the kinds of things that people have asked, what institutions or governments or individuals or minors asked for this, and the statistics tell an interesting story. There are very good reasons for removing some things from the index, especially if it has to do with minors and protecting their interests. But we didn't get a lot of guidance in implementing this.
And the right to be forgotten is a very interesting example of a sort of failure of legal interoperability because it's a product of the European Union's human rights framework under the Charter, and that is explicitly different from the Inter-American human rights framework in the ways that it balances privacy and free expression. So the export doesn't work terribly cleanly, and then if you add on top of that taking a really difficult question about balancing these rights, and instead of having a court do it, you have a private company and Mountain View do it, it becomes very complicated.
So, but this is such a good illustration for those of you who are policy wonks, because here we have an example of worked attempts to deal with individual or human rights that are incompatible, and at least to some extent. And you can imagine what the last 3 days for us have been like, trying to wrestle with buffing down the rough edges of incompatibility to try to reach something that would actually protect people from harm while at the same time protecting their rights. And so when people talk about the right to be forgotten, I sometimes think about, what about the right to be remembered? What about the right not to be forgotten? And there are some things that people shouldn't forget. And then I look at the internet as it currently is formulated, and I realize it remembers stuff you wish it didn't, and it forgets stuff you wish it remembered. And so it has these not very satisfying properties, which happens to be a side effect of the fact that the internet doesn't have infinite capacity to remember everything. And so what you see today is whatever is there. That's what our index shows you. Tomorrow, some of those things that were in the index may have gone away because the website's gone, or somebody forgot to pay the rent on their domain name, and that website doesn't resolve. And if you'll forgive me for one tiny little moment to rant about this, people who make references in their written papers to URLs are potentially denying the future the knowledge that those URLs had if they don't resolve 10 years from now, or 20 years from now, or 100 years from now. So I have this uneasy feeling of a creeping digital dark age that comes because we can't resolve the references that are in some cases, printed documents, in other cases, online documents. But if the resolution fails, the reference doesn't work. And that makes me feel really worried. You know, I feel like we should be going around sacrificing sheep and making vellum and getting monks to go copy things on stuff that lasts for 1,000 years.
Yeah, and as newspapers, for example, move their entire archives online and get rid of the paper copies of yesterday's news, I think we have all the more to worry about. But I'd like to end maybe on a more positive note. We started with the internet's past. Let's talk a little about its future and the reasons for optimism. I'm interested in hearing what you are excited about, what technologies get you excited, what you think the rest of us should be paying attention to in the positive future of the internet.
Well, so I will tell you that I'm schizophrenic about this, because the same things that get me excited and feeling optimistic and everything else also terrify me. So, you know, the rapid evolution of machine learning is making it possible to get computers to do things that we could never have done before. You know, distinguishing various diseases by looking at photographs and figuring out, you know, that you have diabetic retinopathy, for example. The software actually does a better job than the ophthalmologists do. On the other hand, I imagine the Internet of Things with little pieces of software running in them, and it's running sort of on its own. I mean, there's nobody in the loop, and so what if it makes a mistake? There's nobody to intervene. It's like the elevators in this building. You know, you push a little button and it tells you get in that elevator, and you get into the elevator. There's nothing you can do about it. It's a piece of software. You're now at some programmer's, you know, whim. And I used to make a living writing software, and I know that it's hard to write software that doesn't have any bugs. And so at the same time that I'm excited about the flexibility of software-driven stuff, my wife and I have Teslas, for example. You know, you get up in the morning and you get in the car and you turn it on and it says, guess what I can do now that I couldn't do yesterday because it downloaded a new update. And that's very exciting. At the same time, what if it didn't work right? So I foresee this immense flexibility and adaptability of the world around us, filled with software, and at the same time, I'm worried that the tools that were used to make that software were inadequate to prevent the programmer from making mistakes. And so we certainly want to have a way of fixing the mistakes by downloading new code, and then you get worried, well, what if the code isn't actually the right update? What if it's a piece of malware from some hacker? So how do I tell? Do I need digital signatures and cryptography and other things to make sure that the device is able to protect itself from a bad piece of software? I even tried to get Google to rename our Android operating system Paranoid, but because I wanted to convey to people that it was really worried about protecting your interests, but the marketing people thought that was a bad idea, so we didn't do that.
So I think the time has come to move to Q&A with the audience. I understand there are 2 microphones making the rounds. I've been asked to remind everybody that we're looking for questions, not statements, and to please keep it brief so that we can fit in as many things as possible and have as much back and forth as possible.
Sure. My question's around in the early 80s when you thought about address space and how big the internet could have been. Obviously, we've revamped it, V1 through V6.
Yeah.
I'm curious to hear the conversations, how people thought about it back then.
Okay, so this is one of those embarrassing moments. Bob Kahn and I, around 1973, were starting to do the design of the internet. We just finished working on the ARPANET, which was up and running. It was a national scale system. And so we thought, okay, we know that this is going to have to be a global system because it's going to be supporting the military and they have to be able to go everywhere. How many networks might there be per country? And we thought, well, there should be at least 2, so there'll be some competition. Then we said, how many countries are there? And there wasn't any Google to ask back then, so we guessed at 128 because that's a power of 2, and that's what programmers think in. So there's 256 networks, and then we said, okay, so how many computers per network? And in 73, computers were great big mainframe machines, time-shared, they were in air-conditioned rooms, and they sure didn't get up and move around. But we said, well, okay, how about 16 million computers per network, thinking, this is way over the top. When you do the math, that would have been 4.3 billion terminations for the internet if every slot was filled, so to speak, which was more than there were people, I think, in 1973. Somebody could Google that and check. So we came out with the 32-bit address space, 4.3 billion addresses, and I thought, quite honestly, that this was just an experiment, and that if it worked, that then we would do the obvious thing, which was to do a production model, or a production version. Well, remember I mentioned that it became commercial in 1989. The problem is the experimental network escaped into public use. And so you've been running the 1978 internet since 1983. And around 1992, we realized that we were going to run out of address space because of the number of networks that were proliferating, thanks to local area networks, Wi-Fi, and things like that. So the Internet Engineering Task Force developed IP version 6, which has 128 bits of address space. And that's essentially 3.4 times 10 to the 38th addresses. And I remember saying in a setting like this that that's enough address space so every electron in the universe can have its own web page. Until I got a message from somebody at Caltech, "Dear Dr. Cerf, you jerk, there's 10 to the 88th electrons in the universe and you're off by 50 orders of magnitude." So I don't say that anymore.
Who else is out there? Good.
Hi, I just got back from Singapore and I met a person who showed me a smart light bulb. And they're being given away for free. The only problem is that he told me you shouldn't use this light bulb because each light bulb actually does Bitcoin mining. And even though you get this free light bulb, you're paying $2 or $3 Singapore dollars a month worth of electricity to support the Bitcoin mining because it's always plugged in and always connected.
Wait, they're using this light bulb to do Bitcoin
Yeah,
mining?
well, they're trying to have a million. Well, each individual one doesn't do very much, but once you have 2 or 3 million of them, it adds up.
Yeah, that sounds like the famous statement about a billion here and a billion there, and after a while it adds up to real money. I'm not sure that the algorithms will work terribly well in light bulb scale computing.
My concern is that when I started first using the internet back way long ago, each node had a way to contact the administrator, the responsible party for it, because he was on a certain network, he was a certain sun workstation, back then or a fax. But now if you have trillions of devices right now, which are like sensors, whatever, each with the IoT is a security nightmare.
Oh, well, there's no question that it's a security nightmare. I agree with that.
And we're seeing devices come out where there ain't no such thing as a free lunch, right? And we're seeing things like this case where, yeah, you get a light bulb, but what are you getting out of it?
So I have a suggestion. I mean, they're quite
And
right.
this is the question, is what are we getting out of it?
The question is, how do we manage this?
Yeah, right. So a couple of observations. First one is that if you're a smart consumer, you probably want to have something that's telling you what your IoT devices are doing. And in this particular case, the light bulb would be consuming more electricity than is needed to light the bulb. And if it's consuming as much electricity as the Bitcoin processors do, that will be extremely noticeable, because you probably know that the amount of energy required to do Bitcoin mining is, exponentially growing. So my guess is that you'd very quickly discover that your light bulbs were of a kind that you didn't want to have in the house. And if you're a responsible person, you would tell other people about that. You might even complain somewhere. So I'm not suggesting that it's a trivial thing to do, but it would be pretty hard to hide that particular activity, on top of which we could probably detect the communications activity of the light bulbs once it leaves the house, tries to leave the house, which is why you might want a household firewall to block all communications, in which case the mining of the Bitcoins wouldn't be useful to the miner because you couldn't get access to the coin.
You could even leave the technologists behind and complain to the lawyers. I think is the next question over there.
At the back. Hi. You emphasize the importance of openness in the structure of the internet. Sort of above the structural level, we're seeing the openness eroding in various ways. And I'm wondering if you could identify what you see as maybe the major threats and how we should respond.
Well, one possibility is that if, in fact, openness at the application layer, which is roughly, I think, where you're thinking, it becomes a problem because maybe the application space gets concentrated. The interesting thing is that there's nothing stopping someone from opening up another application on the net as long as the underlying network algorithms and mechanisms are still open. So as an example, when Larry Page and Sergey Brin started their Google application, they didn't have to get permission from either the local ISP or every other ISP in the world to bring up a new service. And so this freedom to open up new products and services, it seems to me, is a counterbalance against the possibility of excessive concentration in a variety of existing services. As long as we make it easy for people to open up a new product or a service, I think there will be some balancing there. And that's why it's so important to retain that open character.
Just to the side here.
Sorry, I'm blinded, but I have faith that you're giving the microphone.
Thanks very much. As you look at the internet today relative to where you began, what surprises you the most?
Well, I will say that the biggest surprise for me was once the World Wide Web caught on after the Mosaic Browser was announced, this incredible avalanche of content flew into the network from people who were not looking for compensation. They just wanted to know that their information was useful to someone else. I mean, it was really an astonishing influx of information. And I hadn't anticipated that people would be so willing to share what they knew simply for the satisfaction of knowing that it turned out to be useful to someone else. So that was one surprise. The second surprise, I think, is the rate at which the users of internet-based technology quickly become so dependent on it. Remember, this is 2018. The smartphone, if you allow iPhone to be the primary example, is a 2007 invention. So it's only been slightly over a decade, and I would bet that most of us in this room are pretty dependent on the versatility and applications of that smartphone. So what has surprised me is the speed with which people adopt and then become dependent on internet-based applications. And that makes me just a little nervous, because what if they don't work the way they're supposed to? What if they're not as reliable as they need to be? We're a very funny breed of person. If you're like me, you don't lie awake at night worrying that the electricity is going to go out, but you do hope there are other people who lie awake at night worrying about the electricity going out to make sure that it doesn't. But we tend not to pay much attention to infrastructure until it doesn't work. It's sort of like when you're on the road and there isn't any traffic, you're just on the road and everything is fine, and then there's a traffic jam and now you're all upset. And so it's only when the infrastructure doesn't work the way we expect it to that we get upset. And I worry about the internet infrastructure and doing everything we can to keep it as robust as possible so people won't be so worried that it doesn't work when they need it to. Which, by the way, raises one other point. If you're going to buy devices that are called IoT devices, Internet of Things, and you're going to use them in the house, make sure that you have determined that these devices will work for you even if the house is disconnected from the internet. Because the last thing you want is a house that doesn't work when the internet service goes away and you can't flush the toilet or whatever it is. And, let's be careful about that.
Right here.
Next question, yeah.
I have a two-parter. First, so what stops someone from seeing all your packets, your credit card, passwords, whatever is going across the internet? And then second, how would you use new technologies, maybe quantum computing, to make the infrastructure more robust on the internet and open?
Okay, so the primary way, the flippant answer to your question is don't put your credit card in the internet, you idiot. But the honest answer is that careful use of cryptographics is very helpful. And so at Google, we strongly urge people to use websites that say HTTPS, which means the secure version of Hypertext Transport Protocol, in which there is an exchange of cryptographic keys so that the traffic is encrypted. The second thing is that it's very important not only to protect things in transit, but to protect them when they are at rest. And so we learned that lesson in 2010 at Google when our system got penetrated by an outside, it was a phishing attack. And somebody figured out somebody's password or managed to obtain it, and then worked their way up and got access to some of the information in the core of our system. At that point, we started encrypting everything at rest as well. So these are good practices to protect information. I'd be very thoughtful, too, about when and where you share that information. Sometimes the website will offer to keep your credit card for you for convenience, and you might decide, no, I don't want to do that. Americans, and sometimes maybe Canadians do too, or sometimes will trade off safety and security for convenience. And I would ask people to think twice about that. One other point, one way to protect your accounts on the net is to use what's called two-factor authentication. We offer it and we use it scrupulously at Google. What this means simply is that even if you have a username and a password, you have another device, which might be your mobile or a small cryptographic device, that is needed in addition to username and password in order to authenticate to the service that you're going to. It's a little inconvenient, but I think good security always has this sort of a reducible amount of inconvenience to it, but it's much safer. With regard to quantum computing, this is sort of it's sort of like blockchain. I mean, everybody gets all excited about this weird new technology which doesn't quite make any sense. The fact is that quantum computing is quite real. We are exploring it heavily at Google. We're working on a 49-qubit system to explore some applications for which optimization is done much more quickly using the quantum methods. So I don't think they will help us particularly to secure the internet. If anything, quantum computing would make security harder because it will actually break one class of cryptographic codes that are currently in use. Fortunately, people who worry about things like that have already got a follow-on cryptographic code that will beat the quantum computing algorithms. But it could allow us to do some optimizations in almost real time that we couldn't do before. So I'm pretty excited about the possibilities there.
Quantum computing is one of the terms, along with machine learning and artificial intelligence, that I hear from journalists a lot, particularly with the question of why can't platforms automatically tell if something is terrorist content and make it come down. And my friend Alex Fierst, who's the legal head of Medium, a blogging platform, refers to them collectively as robot magic. Yeah. Can't the robot magic fix this?
Magic.
Just to the right.
Where's the next? Yeah.
Hi, I'm right over here. Should I stand up?
Where are you? Oh, there you are. I see you now.
Okay.
Just barely, but
Could you possibly touch on net neutrality and how it could affect the international community from your perspective?
So this is first of all, the term net neutrality gets interpreted depending on where you happen to be. So in the American sense, you need a tiny bit of history. In the mid-1990s, there were 8,000 internet service providers in the US. And the way you got to them was you had a modem and you dialed up a telephone number and you jammed the modem into the socket of your phone. And so if you didn't like the service, you could switch to a different service by just dialing a different number. So there was plenty of competition. And that changed almost immediately when broadband communication technology came along, because at this point you needed either a coaxial cable from a cable company, or you needed a fiber or digital subscriber loop on a copper line with a high-speed modem in order to achieve these high bandwidths in tens of megabits a second or more, which meant that the service provider available to any individual shrank down to either a telephone company or a cable company. If you were in the rural parts of the world, you had no choice because there wasn't any. If you were in the suburban part, maybe one or the other kind of company could serve you, and if you were in the more urban parts, you might have a choice of a telco and a cable co. So anyway, that's where we got in the States, and that meant there was less competition for broadband access, which means that the absence of that competition the market was not well disciplined. You had very substantial market power. The consequence of that is that there was potential temptation, and in some cases real action, to interfere with internet service to keep a competitor from offering a product to a customer. So for example, if you were a cable company offering video services and you were also offering internet service, and a competitive video service provider was competing with you through the internet channel, if you recognized that was happening, there was a possibility that you could go interfere with your competitor by messing up the internet service, driving your customer back to your own video services. So we had a few situations where voice over IP, packet switch voice, was interfered with, or interference was done on video services, or there was throttling going on and other things. And without going through the entire series of history, the FCC attempted to discipline the market by saying, here are the rules of the road for behavior. You couldn't block, you couldn't throttle, you couldn't interfere with other traffic just because you happen to be controlling the broadband channel. We've gone through several iterations of the situation at the FCC, and in the most recent cycle, the FCC has abandoned responsibility for assuring that the customers are protected from that behavior. So in other parts of the world, the markets may be more disciplined by competition, in which case the issue is less visible. The one thing I will say is that there is confusion about where the neutrality is to be administered. And for the most part, it's at the access to the internet. What you want is the parties offering you access to the net are not interfering with your choice of destination, with the quality of service that you get, or with any other anti-competitive consideration. And where that is absent, then the consumers lose choice, lose quality of service, and lose the options if there isn't enough competition. So we need to do something to preserve this neutral treatment of the consumers and their interests. And I think that's true everywhere in the world.
I think we have time for one more question.
Just right here at the back here.
Thank you so much. I think that two things that seem to be dominating in terms of the development of disruptive internet technologies. One of them seems to be the issue of innovation, and the other one of trust. So trust seems to be at an all-time low, both with governments and even social media platforms and infomedia giants like Google. And then there's the other piece as well, whereby there's the issue of like the potential hampering of innovation, especially when you develop stuff like proprietary algorithms. And some have even used the analogies of like the drug industry in terms of how innovation has been hampered from a patent perspective. And coming back to the trust issue, there's the issue in terms of these black boxes being used to be able to try and sort of make decisions that you don't fully comprehend how they go about it. So I'm curious in terms of the example that comes to mind is like the issue that's happening right now in Xinjiang in China with the use of the Sesame Credit and the use of all these sort of disruptive internet technologies to try and sort of police the population of there. So I'm curious in terms of when you talk about plausible futures and desired futures, how can you try and sort of address the issues of innovation in terms of making sure that we don't necessarily replicate what the drug industry has gone through in the past 20 years, but at the very same time try and sort of bolster trust in terms of fostering transparency and openness when it comes to issues like algorithms?
So let me start out by observing that some of the hazards can be exposed anyway by transparency. So insisting on some kind of transparency is very important. With regard to machine learning algorithms, that actually is sometimes a challenge because the machine learning is done by exposing a deep neural network to a whole variety of examples and telling it yes or no, you got this right, that's a dog and that's a cat. And at the end, you get this complex collection of weights on the inputs that go in, an image of a dog or a cat. And then what comes out the bottom is a decision, is it a dog or a cat? And explaining exactly what was going on in between is a little difficult. You could show the set of training materials that was used to train the neural network, and that would be helpful to at least expose what was used in order to train the system. On the other hand, the complexities of the neural network and the different ways in which the interconnections can be made is yet another degree of freedom in this subject. But I think the general question is transparency is your friend here by asking the companies that use these systems or make these systems to make it more apparent how those decisions are being made. It's a non-trivial question to answer because of the complexity of machine learning, deep neural networks. I think in terms of regaining trust, which I agree has eroded dramatically in almost every direction, I think we're back again to the transparency question. The more that you can explain what you're doing and how you're doing it, I would think the more trust you could regain. And here, again, I'm a big advocate of trying to be very open about how things work. Modulo protection of intellectual property, which I understand is a significant issue. Nonetheless, I think people would feel much more comfortable if they know what's going on, within some limit of understanding, than having black boxes doing things for them that they can't understand. Which is why I get nervous about the Internet of Things, because that's often just a box with a bunch of software in it, and it does stuff, and I don't know who programmed it. I don't even know necessarily where to find the people that wrote the program if it doesn't work the way I expect it to. And so I'm back to wanting things like escrow for software and other ways of revealing what's going on if there isn't any other place to turn.
So if I can try to sum up an extremely wide-ranging conversation, I think we have some grounds for pessimism. Maybe be careful with your credit card number. If you care about the informational record, maybe keep a paper copy. If you care about the outcome of an automated process, maybe have room for a manual override, or a human in the loop. But we also have great grounds for optimism, in particular in that this sort of, in my mind, sanctified group of technologists are still there, are still building out the internet, and are still doing so on the basis of open architectures that permit unforeseeable new things to happen across the network, and that even as they become more complex, can be made more publicly accountable and more understandable through the transparency mechanisms that you were talking about at the end there.
So that's a nice summary. I would add only one thing to it, and that is that you're right, the internet is still evolving. It was designed to do that. That's a wonderful thing. It's also going off the planet. We now have an interplanetary internet in operation between Earth, Mars, and the International Space Station. It's been operating since 2004 when the two rovers landed on Mars and had some radio problems getting directly back to Earth, so we reprogrammed everything to, that's not Google, by the way, this is a NASA project. We reprogrammed the rovers and the orbiters to do packet switched communications back to Earth, store and forward style. So we're now at the point where that's all standardized and it's available on GitHub, and the spacefaring nations of the world now have the opportunity to adopt those protocols and use them in their space exploration. And when those vehicles have finished their primary scientific purpose, they get repurposed as nodes in an interplanetary backbone. So over the course of the next decades, we're going to grow an interplanetary backbone to support manned and robotic space exploration. And I think that's really cool.
That is unambiguously cool.
So yeah, it really does feel like we're living in the future. So first of all, I really need to think about that, the interplanetary internet. But to be honest, all I can really think about right now is Chinese eggplant, and I'm going to be I'm going to be going home and YouTubing this. So big thanks again to Daphne and Vint for this just fantastic conversation. So I think we should give them another round of applause here.
Thank you. That was super fun. Let's do it again.
So I have a few more thank yous. So first of all, thank you all for coming, and thank you to our live stream audience. And of course, thank you to our sustaining sponsors and tonight's partner, Google. Without their support, events like this are not possible. If you'd like to learn more about the events we do here at Canada 2020, just Google Canada or type directly in Canada2020.ca. And if you really like what we do, we've got a new intern program, so you could come work with us. So finally, I would encourage all of you to stick around, have some conversations about what we heard tonight. And we have an open wine and beer bar in the back. So seeing as I'm the only thing stopping you from wine and beer, I will get off the stage now. So thank you all.